right, now that we've mastered solving algebraic equations with single steps and multi-steps, we are now going to put variables and constants on both sides of the equal sign. So now there's going to be a few more steps than just using the properties additive inverse as well as multiplicative inverse. So let me give you an example of a problem. Let me read the problem to you. 4x plus 5 is equal to 16x plus 3. What is the main goal that we have when we solve an algebraic equation? It is to isolate the variable, which means you need to get the variable by itself. So step one, are there any like terms to combine? Now when I say like terms to combine, that means on the same side of the equal sign. And in this case, there is not. There is only one x and one constant. And on the right side, one x and one constant. Therefore, step one, I can't do anything about it. Step two, is a question. What side are you going to put the variable on? So if there's a variable on both sides, you get to choose which side you want to move the variable to. I have 4x and I have 16. Well, I have to be very honest with you. I do not like to use negatives because I have a tendency to drop a negative. So in that case, I would probably take my 4x over to the other side. Now that is an additive inverse. So what do I have to add to 4x to get rid of it? I have to add negative 4x. So 4x plus 5 is equal to 16x plus 3. I just told you that we need to add the additive inverse, which is negative 4x. Well, of course, I'm going to put it underneath the variable term. So now I'm going to combine, and that additive inverse property has those cancel out. That leaves me positive 5 and 16x minus 4x. That's combining like terms, and that makes 12x plus 3. Now I'm back to what we've had before, and now I have a multi-step problem. My variable is on the right side, which means I need to move my positive 3. My additive identity property says I'm going to add negative 3 to both sides. Therefore, I have reflexive, and when I combine like terms, 5 minus 3 is 2, 12x, and these cancel out again. Am I finished? No. I know that 12x is equal to 2, but what I'm solving for is x. So what do I have to get rid of? I have to get rid of 12. And I do the opposite, or I do the multiplicative inverse, which would be by 12. That gives me x is equal to 2/12. Is that the answer? Absolutely not. You would miss something. Because what can I do to 2/12? I can reduce it. And that would give me 1/6. Am I finished? Nope. What do I have to do? I go back into the original equation and I check it. So I have 4, leave out my x, plus 5. And the question is that equal to 16, leave out, plus 3? What am I going to put in those parentheses? I'm going to put the value that I found, which was 1/6. So here we go. I'm going to multiply by order of operation, which says 4/6 plus 5. And then 16 times 1/6 is 16/6 plus 3. Again, the question is, are those the same? Well, when I add these together, that gives me 4/6 plus 36, which is 36 sixes. And then over on this side, I have 16 sixes plus 18 sixes, which gives me 30. Oh my goodness, let me check. Is my math? Oh, I found an error. 4/6 plus 36 is 34/6. Ooh, glad I caught that. And 16 plus 18 is 34. So is 34/6 equal to 34/6? Yes, it is. What is it? Boom, boom, check, check. My answer is x is equal to 1/6. All right, let's do another one. All right, I have a problem here, and it says -5 is equal to... All right, I have a problem here. It says -5 minus 7x is equal to 16 minus 2x. Step 1 says, are there any terms on both sides that I can combine? Well, I have a constant and a variable, a constant and a variable. So step 1, there's nothing that I can do in this case. Step 2 says, what am I going to choose? Which side am I going to move? In this case, I think I'm going to move my 2x over to the left side. So therefore, when I start there, I'm going to do the additive inverse, which means I'm going to add 2x to both sides. Remember, line up like terms. These cancel out, and that leaves me 16 over here. And then -7 plus 2 gives me -5x, and then I have a -5. Well, I'm not finished isolating my variable. I have to get rid of this number right here. So I think I'm going to add 5 to both sides. Those cancel out. That leaves me -5x is equal to 21. Now I have to get -5x is equal to 21. So what does x equal? So I have to do the multiplicative inverse, which means I'm going to divide by -5 or multiply by -1/5. Those cancel out. X is equal to -21/5. Am I finished? No? Good habit to do, because I caught an error. I go back up into my original problem and I check it. If it comes out correct, then boom, boom, check, check. There is my answer. Well, let me do one more problem. All right. Here is my third and final example. 2x plus 3 plus 3x is equal to 15 plus x. Step 1 says, do I have any like terms to combine? On the right side, you'll see I have a constant and a variable, so no. However, on the left side, I have 3 terms, and 2 of them are x terms. So I'm going to combine those, and that gives me 5x plus 3 is equal to 15 plus x. Now you'll notice I have an x on one side and an x on the other. So step 2 says, what side am I going to move my variables to? Well, I'm going to move them, I think, to the left side. So I got to get rid of that. And how do I get rid of it? I use the additive identity process by adding the opposite. Therefore, those cancel out, and it leaves me 4x plus 3 is equal to 15. Now what am I going to do? I got to get rid of that constant because it can't be on the same side as my variable. So again, I'm going to use the additive inverse, and I'm going to subtract 3 from both sides. That leaves me 4x, those are canceled out, equals 12. And if 4x equals 12, my question is, how much does x equal? So now I use the multiplicative inverse, and I multiply through by 1/4, which is division by 4. And that gives me x is equal to 3. Again, plug that back in here, and I always go to the original in case I made an arithmetic error. And I have, in this case, I would have 2 times 3 plus 3 plus 3 times 3. Is that equal to 15 plus 3? So that would give me 6. 3 times 3 gives me 9. And that side over there is 18. Well, 6 plus 3 is 9. And 9 plus 9 is 18. So does 18 equal 18? Yes, it does. Therefore, my solution is x is equal to 3. So tomorrow when you come into class, we're going to be doing these, and these are called variables on both sides of the equal sign. You guys are very, very capable of doing this. So have a great evening, and I'll see you tomorrow.